look inside your human body, you got 50 trillion citizens. Each cell is an independent living entity sharing one environment. And when you're in health, can you imagine how many individuals that are in that little tiny space? Compared to the number of people on this planet, that makes them look insignificant. And yet they live in harmony. And they're able to share, work together. They have energy exchanges. They exchange an economy of ATP molecules. They support each other. They take care of each other. You want to know how to take care of ourselves and live in the world? Study how cells, human cell, body. Because all the rules for living there are we need to live here. And so that the mission of life is not to go through the concept that we live in a random world and God knows what's going to happen tomorrow. I can tell you what's going to happen. Why? The images repeat themselves over time. So when you look at higher or lower, for instance, I'll give you an example. We talk about particles and waves. Particles and waves. That the waves on the left are nonlinear, the particles are called linear, their structure. And while everybody talks about, let me talk about the waves. I want to talk about the particles. Everybody's missing the picture. You know where the action is? At the interface. Wave hits the particle. That's a chaos zone. That's where the waves and the particles interact, and there's an etching at the surface of the energy of the waves and the physical energy of the particle. And this is a chaos place. And it's the same whether the particles are big or small. The Earth is a particle. The waves of the solar system are the nonlinear waves. And the chaos is where? At the surface of the Earth. And the interesting part about that is what happens at the surface of the Earth. Well, think about this. Before there was life, what kind of chemistry did we have? Inorganic chemistry. Non-life. The kind of chemistry that seeks stability. A rock likes to be a rock. It doesn't want to change. It'll stay a rock for as long as it possibly can. But when pigments evolved, pigments were able to trap photons of light from the sun, the waves, and take that energy of the photon and use it to move electrons, and in the process take inorganic chemistry and create organic chemistry. Yeah, but we're made out of organic chemistry. So what does it say we're actually made out of? And the answer is this. We're made out of the earth and the sun. We are both at the same time. We are energized earth. An energized earth does not want to sit still. Energized earth is an active, moving, organic matrix. And so we are life, but we represent energy, half, matter, half, coming together. And so when we look at life, if we look at the earth before there was any life here, photons would hit the earth, be absorbed, and then the energy would radiate off as heat. But once that inorganic chemistry was endowed with the ability to express organic chemistry, it changed. But in this case, let's just watch what happens here. Organic chemistry is the one that seeks activity, okay? Now watch. Photons of light came down, hit the earth, and after the evolution of organic chemistry, the photons didn't necessarily radiate back away again. The photons were now trapped in a matrix of organic chemistry. So the sunlight is accumulating on the surface of the earth. The earth is energized at the surface. And the waves come from the sun in the solar system. The particles come from the earth. And the chaos zone in the middle is where life occurs. So when we look at it, we can then relate and say, as is above, as is below. Then if we understand it this way, we physically came from the planet, but we energetically came from the sun. And in looking at that, then you could call the planet Mother Earth, because this is the physical origin of where we came from, and Father Sun are the waves.
Here's the issue. Your cells are in a community. They work together in a coherent group just like the community of people. The moment the air raid siren goes off in the body saying our survival is under threat, then the cells get into the bomb shelter. The problem is most of our stresses are chronic. They're there all the time. And as long as we maintain a chronic stress, then the more stress we maintain, the more cells in my body stay in the bomb shelter and don't come back out. And the relevance is the cells will die, the tissues will undergo a disorganization, and disease will ensue. And the consequence? It wasn't the system. It was the belief that went into it. So the bottom line is stress is the ultimate problem that we face if you got here with good genes. And I said 95 out of 100 got here with good genes. And stress does this. It alters the system. The stress signals come in at the cell membrane and activate the protein pathways, which are respiration, digestion, excretion, etc. But here's the issue. If a cell encounters stress, what can it do? I already mentioned a couple of things. Well, I'll tell you what it can do. Number one, it could wall itself off, go into the bomb shelter. And the question is, yeah, I can survive, but not for a long time doing that. So that's a temporary effect. It's the only thing I can do temporarily. Another thing cells can do is that they can secrete things in their environment to try to make their environment happier. But that's a very expensive process because to change the whole environment, I'm always just wasting energy throwing it out. It's like trying to heat Memphis in the wintertime by opening your window and leaving your heater on, figuring maybe all of Memphis is going to get warm. And the bottom line is, no, that doesn't work either. So the third thing that is possible, now this is real exciting stuff. The third thing that is possible is you can adapt. What does that mean? Well, that means change your genes or change your biology to stress. Well, what is adaptation in biology today? There is no adaptation in biology. Why? Because we undergo a belief system called Darwinian evolution that says what? That the changes in the genes, the first premise is all gene random. What does that mean? How can I adapt if my genes change randomly? I don't know. Maybe sometimes they'll adapt. Maybe they won't. And the problem is this. Conventional biology has held for years and years and years the belief that when genes change, they only change by accident and randomly so that you can't ever control the out of the mutation. And so the consequence of that is conventional belief then talks about, well, you know those 95 out of 100 people that, let's say, in cancer, in breast cancer, for example, again, 5% of women have a hereditary linkage, 95% of women don't. Yet 95% of these other women who express the cancer alter the genes. So then what do? We go up to the chart and we say, well, the only way you can alter the genes is randomly, so it must have been just a random event. It's random. Well, that's the belief. So we get rid of the assumption that Darwinian evolution is not the way that evolution really occurred, that there is another way. Well, what is that other way? It was first presented in an article called The Origin of Mutants by John Kish. What he did, he took bacteria that had a defective enzyme. The enzyme lactase. Lactase is an enzyme who breaks down the milk sugar called lactose. And that enzyme is necessary to break down the sugar to extract the energy and the building blocks so the bacteria can use the lactose as a food source to power in division. So these bacteria that Karen starts with have defective enzymes for lactase. They cannot eat. That's the truth. So he takes these bacteria and he puts them in a petri dish, and the only food he put in the petri dish is lactose. Talk about stress. These little bacteria guys were going, oh man, it's eating here. Well, the problem is this. When there's nothing to eat, they can't divide. And when they can't divide, they can't reproduce the DNA, which is generally where the source of the mutations occur. And the result is they can't divide, they can't change the DNA. We expect nothing to happen. And yet, in all the petri dishes, after a few days, there are bacterial colonies growing in every one of them. And the question was that Karen said, how the heck did that happen? Conventional understanding says that these can't divide because there wasn't any energy, so they can't change the DNA. How did they change the DNA? So when he examined the DNA, what he found was they didn't randomly change a whole bunch of genes. They focused on the genes for lactose, the lactase enzyme, and they changed just the lactase gene, even though they weren't dividing. It was a whole new mechanism, a whole new concept. And the interesting part about it is, when he reported this, the British journal Nature, heresy in evolutionary biology. What's a heresy? Demonstrated that bacteria can choose which mutations they should produce. That's a whole new concept. And the interesting part about it is, they're so upset. And the answer is this. Think how profound it is. If mutations can occur as a result of adapting, then mutations are not necessarily random. And if mutations are not random, then evolution wasn't an accident. We didn't get here by accident. We got programmed. The relevance of this is that we actually got here through a process of creation and evolution simultaneously occurring. That the organisms were pre-adapting to the environment, and the signals in the environment were shaping the organism, so that evolution was an accident. This is the flow chart, the Darwinian flow chart. How does it work? It says organisms at the time and they mate, they create variants in the part of the reproduction phase, which is the belief that DNA gets altered. Now, I'm going to show you the new flow, and it becomes very relevant for this reason. Yes, organism, and there are three variants in genes. What did they find? that in every nucleus, in every cell in your body, you have genes whose function it is to rewrite the other genes if they encounter